Okay, so we are starting now. Can I please have silence? Can I please have silence? Laiba? All right, so we started functions and we have done a few concepts already. We have talked about function notation. Uh, we have done inverse functions, how to find inverse of a linear function at least. That is what we have done. We've talked about domain and range of different kinds of functions. We know how to find range of linear functions now. We know how to find range of quadratic functions. All right. And we also know how to find range of reciprocal functions now. That's what we did in the last session, right? So when you have to deal with the concept of infinity sometimes, that's what we looked at. And yeah, so there was one question that I asked you to do in the last session. How many of you have attempted this question? The same 5-6 people जो हर क्लास में करके आते हैं, बाकियों को याद भी नहीं होता कि क्या किया था हमने लास्ट टाइम में. Yes, Iman, you did this question, right? Okay. Uh, can you raise your hands again? Okay. Yes, Iman. Y between 0 and 1 over 9. Okay. Any other answers? Between 0 and 1 over 9? Did everyone get this? Okay, children. Let's try this. And then we move on to the next concept. So we have this function 1 over x minus 2 whole square. The domain is x greater than 5. How do we think about this? We say the least value that we have is 5, all right, or just above 5. And the greatest possible value in the domain is infinity. All right, so the domain is going from 5 to infinity. So we see what happens, we think about what happens at 5, and we also think about what happens when x becomes very large when it goes towards infinity. All right, so ये दो चीजें आपने देखी हैं. Can you input 5 in this function? 5 आप input कर सकते हैं इसके अंदर. If you do that, f of 5 gives you 1 over 5 minus 2 whole squared, and that is 1 over 9. So this is one extreme point that we have for the range. Okay? Now what's the other end of the domain? It's infinity. So now you think about what happens if x becomes very large. All right, x की value बहुत बड़ी हो जाती है. So what happens to this function? You can think of it in your head as well. Denominator बहुत बड़ा हो जाएगा. 1 over that large number is going to approach 0. आप इस तरह सोच भी सकते हैं. Otherwise, another idea is that you input a large number on your calculator. Calculator पे infinity के जगह पे आप कोई बड़ा number डाल दें. Alright? So कोई भी बड़ा number डाल दें. Let's say, so add as many zeros to 1 like this, maybe 100,000. आप ये input करके देखें calculator में. You'll get some value for this. What do we get? 110 is for minus 20. So that's an extremely small number, right? बहुत छोटा number. 10 raised to the power minus 20. So you can say this is almost equal to 0. बिल्कुल 0 के पास ही होएगा ये. Okay? So what's your range then? You would say range is between 0 and 1 over 9. Now you need to think about whether we should put equality signs with 1 over 9 or 0, or we should not do that. What do you think? 1 over 9 के साथ equality sign आएगा? 1 over 9 के साथ नहीं आएगा because वो आ रहा है 5 के corresponding. 5 was not part of the domain, so 1 over 9 is also not going to be part of the range. So 1 over 9 के साथ तो उससे नहीं लगाएंगे. What about 0? Should we have 0? Should we have an equality sign with the 0 here? Why not? डिनोमिनेटर 0 नहीं हो सकता, लेकिन y की वैल्यू की बात हो रही है ना. पूरे y की वैल्यू ये 0 क्यों नहीं हो सकती? I was just answering Eamon's question. So can somebody else explain this again? Why can't it be 0? The graph never touches. Okay, so let's say we don't know about the shape of the graph. Yes? If x is 2, y would be 0. Yes, ma'am. Why nothing? What does that mean? 1 divided by an extremely large number would be something very small, but not exactly 0. बहुत छोटा हो जाएगा, लेकिन 0 को exactly 0 के equal नहीं होगा. All right? तो ऊपर न्यूमरेटर में 1 तो है ना आपके पास, तो exactly 0 तो नहीं हो सकता है. So 0 के बिल्कुल अप्रोच करेगा, but it's not going to be equal to 0. तो यहाँ पे 0 के साथ भी आप इक्वालिटी का साइन नहीं लगाओगे. You would say range is between 0 and 1/9. Is that all right? Any problem with this? No? Is that okay? All right. So that's about range of functions. Now let's move on. The next thing we want to do is we want to figure out how to find inverse of non-linear functions. For now, we only know how to find inverse of linear functions, right? What if you have functions which are not linear? उनके inverse कैसे निकालेंगे? Yes. It can't be negative as well because see, uh, no, it's a square. It's a square, right? So you always get positive values. You can say y greater than 0 in that case. But x less than 5 में ना आपका asymptote आ जाता है दरम्यान में. So then you have to know about the graph. Or at least think of the asymptote कि अच्छा x equals 2 के ऊपर asymptote होएगा, वो भी आपका डोमेन के अंदर आ गया है. फिर आपको 2 के आसपास देखना पड़ेगा क्या होता है फंक्शन को. 2 के आसपास फंक्शन would be going to a very high value. और फिर आप देखोगे अच्छा मिनिमम वैल्यू 0 है, बिकॉज जब x की वैल्यू बहुत छोटी हो जाएगी नेगेटिव साइड पे, तो वहाँ पे 0 को अप्रोच करेगा. और पॉजिटिव साइड पे इन्फिनिटी पे जा रहे हैं, so range is between 0 and infinity. But they don't give you such questions in A levels जहाँ पे आपका asymptote डोमेन के अंदर आ रहा हो. Okay, so that's why they have given the right hand side, because वहाँ पे asymptote नहीं आता, तो आपको सिर्फ end points का सोचना है, asymptote का नहीं सोचना. Okay, sorry I cut you off. Yes, they won't because we have a square, right? Yes, so it becomes steeper, but 1 over x square graph looks like this, and this. 1 over x square graph. Now, if this is x minus 2 whole square, the graph is going to shift to the right by 2 units. So it would look something like this. You have an asymptote at x equals 2, and the shape would look like this. Okay, but it never goes below the x-axis. Okay, the rest of you don't get confused. You don't get this in A levels. एसिम्प्टोट दरम्यान में नहीं आ सकता डोमेन. ठीक है, आपके पास या तो वो इस साइड का पूछेगा आपसे, या फिर आपसे वो इस साइड का पूछेगा. ओके, सो व्हाट दे आर आस्किंग फॉर इज व्हाट इफ द डोमेन इज टुवर्ड्स लेफ्ट ऑफ लेट्स से 5, इसके लेफ्ट साइड वाला डोमेन. अब उसमें मसला ये है कि आपके पास ये पार्ट भी आ रहा है ग्राफ का और ये पार्ट भी आ रहा है, तो दरम्यान में आपका ग्राफ इन्फिनिटी की तरफ जा रहा है. सो हाउ वुड यू नो कि ग्राफ इन्फिनिटी पे जा रहा है, नेगेटिव इन्फिनिटी पे जा रहा है? That makes things a bit more complicated. You don't get these questions in A levels. Okay, but this is how it would look like if you were to figure this out. ये clear है? Okay, so even if it's not, it's all right. It doesn't matter. Let's move on. Let's move on to the next concept, and that is if you have to find inverse of non-linear functions which are not linear. Okay, उनके inverse कैसे निकालें? That's what you want to do now. Now for that you need to understand the types of relationships we have between different variables. Let's say you have two variables, x and y. They can be related to each other in uh, a number of different ways. Okay. Let's say you have x and you have y. There are four different types of relationships that you can have between them. One is called one-to-one relationship. One-to-one relationship. Then you have many-to-one. Then you have one-to-many and many-to-many. Now, what exactly does this mean? Let's try to understand this. So there are four different types of relationships: one-to-many, one-to-one, many-to-one, one-to-many, and many-to-many. Now we are going to focus on the first two, but I'll tell you quickly what the third and fourth mean as well. But हमारा focus first or second पे होगा because only the first and two are functions. बाकी functions नहीं होते. We'll talk about that. Let's understand each of these different types of relations one by one. Number one, we have one-to-one relationship. One-to-one relationship. Now, what this means is if you have a function that looks like this, for instance, have you done exponential function? Log किया हमने कब? Log हमने कर लिया है. Yeah. So you know about exponential function. Let me use that here. Y equals e power x. This is the function that I have. Y equals e raised to power x. How does the graph of this function look like? It goes like this on the left side, and then it increases like this. And this is what the graph of e power x looks like. Now this graph cuts the x-axis at 1 because when you input x equal to 0, the value of y is 1. And then it keeps increasing like this. This is what the graph looks like. Now, if you were to input different values of x in this function, you can try that. For instance, you have x here, you have y here. If you input x equal to 0, what value do you get? You get y equal to 1. If you input, or you can actually make those ovals here first. Okay, let's take different values of x and y in this. Let's say we input x equal to 0. What value do you get? You get 1 from that. If you input x equals 1, that gives you e raised to power 1. You can just write e there. If you input, let's say x equals 2, what do you get? You get e raised to power 2, and so on. You could try different values of x. They give you corresponding values for y. Now, every value of x here can only give you one single value of y. Okay? Every value of x is giving you one value of y. And also, every value of y in this function is coming from only one particular value of x. What that means is, if you look at the graph of this function, you have this x value here. Now when x is equal to this, there's only one corresponding y value, and that's this one. So x1 corresponds to y1 here. All right. If I were to take another x value, let's say that's here, this just corresponds to this one y value. Similarly, the other way around, every y value corresponds to only a single x value. Okay, हर इनपुट की सिर्फ एक आउटपुट हो सकती है और हर आउटपुट सिर्फ एक इनपुट से आ सकती है. That's the idea. Okay, so let me actually write this in function. No, not a function notation. हर x की वैल्यू के लिए एक y की वैल्यू हो सकती है और हर y की वैल्यू के लिए सिर्फ एक x की वैल्यू हो सकती है. That's the idea. Make sense? This is called a one-to-one relationship. 1x, 1y. So the पहला one लिखा हुआ है यहाँ पे, that corresponds to x, and the second corresponds to y. For every x value, for every one x value, we have only one y value. That's why we call this a one-to-one relationship. Make sense? All linear functions are also one to one because वो straight line होते हैं. हर x की वैल्यू के लिए सिर्फ एक y की वैल्यू आ रही होती है और हर y की वैल्यू के लिए भी एक x की वैल्यू आ रही होती है. बट लीनियर के अलावा कुछ और फंक्शंस भी हो सकते हैं. फॉर एग्जांपल लॉग का ग्राफ वन टू वन होता है, एक्सपोनेंशियल फंक्शन का ग्राफ वन टू वन होता है. दीज आर वन टू वन फंक्शंस. मेक सेंस? This is a one to one relationship between these two variables. Any problem with this? No? Now let's consider the second type of relationship. The second one is when you have a many to one relationship. Many to one relationship. Now, can you think of a graph in which if you had two values of x and they give you the same values of y? Is that possible? Quadratic functions, right? So quadratic functions में क्या होता है? They look something like this. So we have, let's say, the x-axis here. You have a graph that looks like this, for instance. Now it's a U-shaped graph. It could be another possible shape as well. Let's say this corresponds to y equals x squared plus 2. This is the equation of this graph. Now this is how the graph of this function would look like. It's a U-shaped graph. Now in this graph, in this equation, if you were to input different values of x and y, let's see what happens. So again, let's take some example inputs and their corresponding outputs. We have x values here and we have y values here. Let's say we input -2 in this. What does that give us? -2 input करते हैं क्या मिलता है? 6. Let's input -1. That gives us 3. If we input 0, that gives us 2. If we input 1, that gives us 3 again. And if we input 2, that gives us 6 again. Now, this is not one to one because multiple values of x are giving you a single value of y. All right. So, for instance, if this was y equal to 6, if 6 was here, you're getting a value of 6 at -2, and we're also getting a value of 6 at +2. -2 and +2, they are both giving you the same value. And similarly, if this was 3, this can't be 3, let's say this is 3, -1 and +1, they're also giving you the same value. So there are multiple values of x which are giving you the same value of y. So you can say many values of x can give you one value of y. Multiple x are giving you a single y. That's why it's called a many to one relationship. You can have multiple inputs, and multiple inputs can give you one output. This is a many to one relationship. Is that okay? Yes.
Is it necessary that the output must be on the y-axis?
Yeah.
Why?
That's a convention that we have. Anything that we take as input, we plot that on the horizontal axis. Anything that we take as the output, that's plotted on the y-axis.
For example, if I input something in y, तो x पे तो आएगा तो वो output हो जाएगा.
वही ना, अब डिपेंड करता है ना आपने क्या आपने इनपुट किसको लिया और आउटपुट किसको लिया. अगर आपने y को इनपुट लिया है, then that could come on the horizontal axis. अगर आपने x को आउटपुट लिया, that could come on the vertical axis. इनपुट आउटपुट पे डिपेंड करता है. वेरिएबल के नाम से फर्क नहीं पड़ता. वो डिपेंड करता है आप इनपुट क्या कर रहे हो. यू टेक दैट एज द हॉरिजॉन्टल एक्सेस. जो आउटपुट आपको मिलती है, टेक दैट एज द वर्टिकल एक्सेस. तो वेरिएबल का नाम कुछ भी हो सकता है. इज दिस ऑल राइट? This is a many to one relationship. Achha, now let's talk about another relationship, then that is one to many. One to many relationship. Anyone who can think of an example for this one to many relationship? One value that's giving you multiple outputs. Yes, Lena? Inverse trig functions? Okay, let me show you the graph of inverse trig functions. Achha, inverse trig functions. You don't mean reciprocal, you mean inverse trig. Okay, all right. Yeah, that would make sense. That circles are not one to many; they are many to many. They're many to many. But yeah, inverse trig functions that would work, or as the other Zena pointed out, square root functions. If you have plus minus with that, then you could think of a function like this: y square equals x plus 2, or let's say y square equals x plus 3. Functions like these जहाँ पे y का स्क्वायर है और x स्क्वायर, ये आपके पास इस तरह की शेप बन जाती है. It's going to look like this, a C-shaped graph. Okay, it'll look something like this. Not rotating. It's a reflection in the line y equals x. It's kind of the inverse of that, right? Because you're taking square root here, interchanging the variables. Yeah. This is how the graph of this function looks like. Now, I'm not sure about the specific values. Let's try that. 0 pay, we should be getting something positive or negative. That's okay, but they should both be. Just give me a minute. 0 at 0, we should be getting equal value. So it will look something like this. And it starts when x is minus 3. Yeah. So this is how the graph looks like. Okay? Yes. No, the inverse of each other. The inverse function of each other. So if you have, for example, y equals x square, y square equals x would be kind of the inverse function of that, right? But we don't even call it a function. In fact, it's not a function, which we'll talk about, Abhi. But yes, it's kind of an inverse, but we don't call it inverse. Yes. No, you don't. ये basically ये function है y equals plus minus square root of x plus 3. The same equation है, उसका graph इस तरह का लगता है. But you don't have to know the shape of this. If you had to draw this graph, you would just take values, input values, plot those values and just join them using the graph. आपको shape पता होने जरूरी नहीं है. ठीक है? अच्छा खैर, this is a possible example of a one-to-many relationship. Why? Because in this case, if you were to take some values of x and y, you would realize that one value of x is giving you multiple values of y. Okay. So for instance, let's try something here. Let's input let's input x equal to 1 here. If we input x equal to 1, what value of y do we get from that? 1 input karte hain, it becomes 1 plus 3, that's 4. Take square root of 4, but you have to put plus minus there. You get plus 2 or minus 2. You're getting two values of y from x equal to 1. All right. If we input minus 2, for instance, that would give us 1 and also minus 1. So basically the idea is one value of x is giving us multiple values of y. So if you add this x value, for instance, this is giving you one value of y here. This is y1 and another value of y here. You're getting two values of y. So one input is giving you many outputs. So that's why we say this is a one-to-many relationship. One input can give you multiple outputs. So it's a one-to-many relationship. Make sense? This is the third kind of relationship. So we did one-to-one, many-to-one, and then one-to-many. Then there's this last type that is many-to-many relationship. Can you think of an example of that? We've done this before. Sorry? Many-to-many relationship. Something that can give multiple outputs for a single input, and also a single output can come from multiple inputs. So it's a many-to-many relationship. एक x की वैल्यू से मल्टीपल आउटपुट्स भी आ सकती है, मल्टीपल y की वैल्यूज भी आ सकती है, और एक y की वैल्यू मल्टीपल x वैल्यू से भी आ सकती है. What kind of a graph would that be? We've done this. Circle, right? Circle के ग्राफ जो होते हैं, they are many to many relationship. Let's try that. Many to many आप ग्राफ बनाते हो, अगर सर्कल का ग्राफ बनाते हो, it looks something like this. Now it could be a circle, it could be an oval as well. उनके ग्राफ भी ऐसे होंगे. Let's say this is a graph. Okay. अब इसमें क्या है? If I take one value of x, let's say I take this value of x. This is x1. At this x1, I'm getting one value of y here. This is one value of y. And I'm also getting another value of y on the lower side. This is the second value of y. So one input can give me multiple outputs. And also, if I were to take one value of y, for example, this value of y, let's call this y2. This corresponds to one value of x here and also another value of x here. So one input is giving me multiple outputs, and one output can also come from multiple inputs. This is a many-to-many relationship. All right? ये clear है सबको? There are four different types of relationships that we have: one-to-one, many-to-one, one-to-many, and many-to-many. Okay? Now let me just write them down here again. These are four different types of relationships: one-to-one, many-to-one, one-to-many, and many-to-many. Okay. So first of all, we have a one-to-one relationship. Yes. Yes. So it says multiple outputs, right? So the quadratic is just an example. Cubic is also a many-to-one function. All right. Now there are four different types of relationships here. One-to-one relationship. अच्छा एक तो ये word है, ये terminology है relationship. There are four types of relationships. Then there's another terminology that we use in maths, and that's called a function. Okay, function. A mathematical function is a relationship that has only one output. A mathematical function is defined like this, that it can only have one output. So only these first two types are called functions. The third and fourth types, you have equations that are one to many relationships or many to many relationships, but we don't call them mathematical functions. All right, उनको हम function नहीं कहता. Now how many of you do computer science? None of you. No one here studies computer science. Oh, that's sad actually. Why are you not studying computer science? आजकल तो आपको CS पढ़नी चाहिए. आप तो वैसे इतना स्मार्ट है माशाल्लाह सब. Yes. Okay. IT पढ़ते हैं? How many of you take IT? IT का भी क्लास है? IT कौन कौन लेता है? No one? Okay, all right. Okay. All right. So there are two types of functions. There are two types here of relationship which are called functions, one to one and many to one. Now, if you had studied computer science, you would know that there are functions which can give multiple outputs as well. लेकिन मैथ में हम फंक्शन इस तरह डिफाइन करते हैं, समथिंग मोर हिस्टोरिकल बेसिकली, ज़्यादा यूजफुल फंक्शंस और या ज़्यादा कॉमनली यूज्ड फंक्शंस वो होते हैं जो जहाँ पे सिंगल आउटपुट आ रही होती है. मल्टीपल आउटपुट्स वाले फंक्शंस एग्जिस्ट करते हैं और फील्ड्स के अंदर, लेकिन वो इतना ज़्यादा कॉमन नहीं है. आजकल ज़्यादा कॉमन हो गए हैं, बट इट्स मोर ऑफ हिस्टोरिकल. इस तरह से शुरू से चलता आ रहा है. क्या ये जो फर्स्ट टू टाइप्स है ना, इनको फंक्शंस कहते हैं. थर्ड और फोर्थ टाइप्स को फंक्शंस नहीं कहते. ऑलराइट. Now, functions are just defined like this. Mathematical functions are just defined like this, that you have to have only one single output. All right. Now, since only the first two types are functions, and we are doing a topic that's named functions, we are not going to be dealing with the third and fourth types here. ठीक है? ये हम नहीं देख रहे होंगे यहाँ पे. We will only restrict ourselves to the first two types of relationships, one to one and many to one. Is that okay? So the first thing that you understand from here is a function is a relationship that has only one output. Multiple outputs नहीं आ सकती, single output से. Okay? So you have only these two functions. अब इनमें से अगर हमने इनवर्स निकालना, वन टू वन फंक्शन का इनवर्स एग्जिस्ट करता है, मेनी टू वन फंक्शन का इनवर्स नहीं एग्जिस्ट करता. The reason for that is, remember when we find inverse functions, what happens? Inputs and outputs, they interchange with each other. वो switch हो जाते हैं. अगर आप वन टू वन का इनवर्स निकालोगे, वो भी वन टू वन ही आएगा. आप इनपुट और आउटपुट को इंटरचेंज कर दो, एक्स और वाई को इंटरचेंज कर दो, इट्स स्टिल वन टू वन. बट इफ यू फाइंड इनवर्स ऑफ अ मेनी टू वन फंक्शन, इनपुट और आउटपुट इंटरचेंज होंगे, तो ये बन जाएगा वन टू मेनी, एंड दैट इज नॉट अ फंक्शन. वन टू मेनी फंक्शन ही नहीं है, तो इसलिए हम उसका इनवर्स नहीं निकाल सकते. Is that okay? वन टू वन का इनवर्स भी वन टू वन होगा, सो दैट वर्क्स. मेनी टू वन का आप इनवर्स करेंगे तो एक्स और वाई इंटरचेंज होंगे, वो वन टू मेनी बन जाएगा. वन टू मेनी फंक्शन ही नहीं होता. दैट्स व्हाई वी डोंट फाइंड इनवर्स ऑफ दोज फंक्शंस, मेनी टू वन फंक्शंस. Is that okay? Now we are only going to focus on the first two lines here, not the third and fourth line. That's just for understanding कि वो दो types जो हैं हम यहाँ पे नहीं consider करें. We still call them equations, we still call them relationships, the third or fourth है, but हम उनको function नहीं कहते हैं बस. Okay? Yes, sir. But that's not even a function, so that's originally is not a function, so we don't deal with that, right? One to many खुद function नहीं है, तो फिर हम उसको use करते नहीं हैं यहाँ पे. Okay? Is this okay? Any problems? No? वन टू मेनी फंक्शन ही नहीं है ना, तो उसका हम इनवर्स निकालेंगे नहीं. किसका? वो फंक्शन ही नहीं है ना, तो उससे उनको तो हम देख ही नहीं रहे. वी आर नॉट इवन कंसिडरिंग देम, राइट? तो वो इस टॉपिक में है ही नहीं. हम इनवर्स सिर्फ निकालने की कोशिश करेंगे फर्स्ट टू का, उनमें से सेकंड का नहीं एग्जिस्ट करता, फर्स्ट का एग्जिस्ट करता. ऑलराइट, ये क्लियर है सबको? अच्छा, now you need to be able to figure out whether a function is one to one or many to one by looking at the graph of the function. Okay? Now look at the graph of this function. इस फंक्शन में हर इनपुट के लिए आपके पास सिंगल आउटपुट है, और कोई भी आउटपुट मल्टीपल इनपुट से नहीं आ रही है. टू वैल्यूज ऑफ एक्स आपको सेम वैल्यू ऑफ वाई नहीं दे रहे हैं. दिस इज वन टू वन देयरफॉर. ओके, व्हेन इन द क्वाड्रेटिक फंक्शन we have two values, we can have multiple values that are giving us the same output. We have a test that we use sometimes to figure out whether a function. Okay, we don't have a test right now. Okay, so there is a test that exists that we can use to find whether a function is one to one or not. Graphical test है. वो क्या है? You try to draw a horizontal line on the graph and you see कि अच्छा, can you draw any horizontal line on the graph that cuts the graph at more than one point? Can you draw any horizontal line here that would cut the graph at more than one point? You can't. आप जो मर्जी line बनाए, it would only cut the graph at one point, right? But look at this graph. Can you draw any horizontal line that would cut the graph at more than one point? You can. If you draw a line here, that cuts the graph at more than one point. Now, if it cuts the graph at more than one point, it's not a one-to-one function. If you can't figure out any such line that would cut the graph at more than one point, then that function is a one-to-one function. Now, we're talking about at least one line. क्या at least एक line ऐसी बना सकते हैं जो दो points पे cut करे? We can. Okay. Now you might think कि अच्छा, ये नीचे भी तो line में आ रहे हैं, but this is not cutting the graph at any point. या फिर हम यहाँ पे line बना रहे हैं that only cuts the graph at one point. The question is, can we draw at least one line that would cut the graph at more than one point? Yes, we can. Then it's not a one-to-one function. ठीक है? At least एक बना सकते हैं, so it's not a one-to-one function. Okay. Just let me just summarize this. यहाँ पे नीचे लग जाते हैं. Horizontal line test, then we have a break after that. Horizontal line test. You basically ask yourself, can you draw any, or let's say, can you draw at least one horizontal line All right, so that's what the horizontal line test says. If you can draw at least one horizontal line on the graph that cuts the graph at more than 1 point, then it's not a one-to-one function. If you cannot draw any such line, then it is a one-to-one function. All right, that's what the test says. We have a 5-minute break. It's 2:03. We resume at 2:08, inshallah. Okay. This is the clock that we are following. 2:03 is पे हो चुके हैं. 2:08 पे we end. Okay. If you come back according to that clock, class will also end according to that clock then. Okay. 5 minutes. Yes. Why not? When does it start? कौन सा स्लॉट? फ्राइडे को तो नहीं होता ना, वो जुमा होता है उस टाइम पे. 8 की क्लासेस होती हैं फ्राइडे को फ्रॉम 10:40 to 12:50. So 10:35 to 11:45 and 11:45 to 12:55. ये दो स्लॉट्स हैं. फ्राइडे 11:45 to 12:55 किसकी क्लास होती है? कौन सी क्लास होती है? बिजनेस की क्लास होती है. मंडे 10:40 to 11:50. आई थिंक हम सारे चेक कर चुके हैं एक दफा पहले, है ना, सारे स्लॉट्स. एक हमने स्लॉट डिसाइड भी किया था. वेंसडे 1:10 to 2:20 वेंसडे. एक ग्रुप में भी पोस्ट किया था हमने एक दफा, यू रिमेम्बर. फ्राइडे को भी एक किया था. क्लास 30 मिनट्स पहले शुरू करने का. अच्छा, वेंसडे वन बस एक स्लॉट लगा हुआ है. सैटरडे वाली क्लास हमने नहीं, उस तरह क्लासेस आ रहे हैं, हम क्या करें. वेंसडे को कर लें उसको. नहीं, एक एक्स्ट्रा क्लास करनी है, शिफ्ट नहीं करनी। 10:30 to 12:10। या हमने क्या क्या किया था? 11 to 12:30 इस तरह कुछ किया था। नो नो नो, सैटरडे। 10:30 ऑनवर्ड। वेंसडे सैटरडे लिखा हुआ है। सॉरी। डिफरेंट टाइम्स पे होता है ना, यहाँ पे 1:15 होता है, इधर काफी अर्ली हो जाता है। आसपास 1:40-1:45 पे हो रहा होता है। सॉरी। फ्रॉम 1 to 2:20। सॉरी। या अच्छा, हमारे पहले डिसाइड हुआ था वेंसडेज। सॉरी। Actually, what would happen would be, since I don't have A2 classes anymore from next week, अगर तो आप लोगों की जुम्मे से पहले शिफ्ट हो जाती हैं तो फिर तो हम उस टाइम स्लॉट पे कर सकते हैं। Otherwise, I would be coming from home at that point, at that time. So I'll pray Juma somewhere close to my home, and then I'll come for class. Okay, so it's already posted on the group. We have extra classes from next week. Wednesdays 1:10 to 2:20. It's already decided. हो चुका है, decided है। Okay, Wednesday, Wednesday 1:10 to 2:20. There is no clash at that point. We've already confirmed this. Asma का clash था? लेकिन आपने कहा था कि आप उर्दू की क्लास को मिस कराएंगी और आप मैथ्स की क्लास। सॉरी। बिजनेस की क्लास दूसरे ग्रुप की अटेंड कर लेंगे, कर सकती हैं आप ये। ओके, सो फला हैज अग्रीड टू दैट, वी कुड डू दैट। नहीं नहीं, वो किसी और ग्रुप के साथ वो कर लेंगी। अच्छा, फ्राइडे को किस किस का क्लास है? 11, वो टाइम 11:45 to 12:55 आपकी। अच्छा 10, अच्छा क्लास है, असमा का भी क्लास है, आपका भी क्लास है। असमा कौन सा क्लास है आप? अच्छा आप सेम क्लास में है। बिजनेस के दो ग्रुप्स होते हैं इस टाइम पे, और टीचर भी डिफरेंट है ऑफ कोर्स पे। एक टीचर दो ग्रुप से ऐसे पढ़ा, नहीं सेम टाइम पे दो ग्रुप्स नहीं पढ़ा सकते, यू कांट बी। असमा अपना स्केड्यूल देख के मुझे बताएं किस टाइम पे आपकी क्लास है, कल आपकी किस टाइम पे क्लास है। ओके, आई थिंक वी कांट डू मच। सॉरी।